In our last video, we saw this definition of work. That if I wanted to calculate the work done by a force field F in moving an object from A to B along this path, then I just evaluate the line integral of F over C of the path C. And so in this video, I want to find the work done by the force field F, which is xyi plus yj minus yzk, and moving an object from the origin to the point 1, 1, 1 along the path. R of t is ti plus t squared j plus tk. Well, the first thing I know I'm going to need is I'm going to need an interval for t. Well, just looking at the x-coordinate, since t is literally the x-coordinate, well, if I start at the origin, I need to be at 0, and if I'm going to end at 1, I need to end at 1, and we should at least glance and make sure that is consistent and works for all three parts, but luckily for us, in this one it does. So what we're doing now is calculating a line integral over the path C of this vector field, which for this example I think I'll use this formula. So I need to calculate f of r of t and dr dt. All right, so let's see. X times y, plugging my path in, that's going to be t times t squared is t cubed. In the middle here, I just get y is t squared, and the k component, I have minus yz, so that's going to be minus t cubed. So there's f of r of t, and now I need to calculate dr dt. All right, well, dr dt 1 comma 2t comma 1. Now my integrand becomes a dot product of these two things. So I'm integrating from 0 to 1 of the dot product of these two things, dt. Well, when I do the dot product, I have a t cubed minus a t cubed, and that goes away, and I'm just left with a 2t cubed. All right, find my antiderivative, and I'm looking at 1/2 t to the 4th. Evaluated from 0 to 1, and we get 1/2. Well, when I wrote this problem down, I didn't establish any units, but here at the end, let's have a conversation about units. And let's say this force had units that were newtons, and let's say the distances in the x, y, and z direction were being measured in meters. Then the correct units here would be the Newton meter, or you could in fact say the joule. Now, if you're working a problem that doesn't have units stated, don't just assume they were newtons and meters, right? Just work the problem and state an answer. And if you really wanted to, we could write units next to it in place of joules, or you could say force distance here, because it's really a unit of force distance here for work. And of course, if there are units, then use the correct ones.